histograms. Histograms are actually very much like bar graphs, except they represent data that's been grouped into classes. So for example, if we had a frequency table that was about time spent on homework per day, and then we had our frequency table, so this is time in minutes and frequency. Here, instead of having a unique value, you would have a range. So 0 to 59 minutes, 60 to 119 minutes, 120 to 179, 180 to 239, 240 to 299, 300 to 359, and more than 360 minutes. So this means that the frequency is any number of answers that came within that range. So let's just say 1 for this, 14 for this, 3 for this, 5 for this, 6 for this, 2 for this, and 1 for this. So if we were then going to graph with a histogram, you'd have many of the same things as you would have for the bar graph. So first, a title. Time in minutes spent on homework. You would have a label for your x-axis, time in minutes. You would have a label for your y-axis, frequency. You would have the individual designations for the x-axis, so you always start at 0, then you'd have 60, 120, 180, 240, 300, 360. And you notice that these are actually not the end values, but rather the beginning values that are listed, because you're starting at 0, you're going to 59 in one class, in one grouping, but you continue the next grouping in 60. So there's no overlap so that it doesn't get confusing and one class is not bigger than the other. But there is a kind of overlap in terms of the numbers being continuous. You also have to have You also have to have your frequency values. So given the range of numbers, let's say that we're going to do 5. Again, the beginning would be 0, 10, and 15, just to show you that a scale could be different, but there's enough space in there so that you can see the individual ones as well. So then we would begin. From 0 to 60 had only 1. From 60 to 19 had 14. And you see how in this case the bars are actually touching. There is no separation between them. 120 to 180 had 3. 180 to 239 had 5. 240 to 299 had 6. 300 to 359 had 2. And then we have 1 here. Okay, so you've shown all of your data. So this would be how you create a histogram based on information that you were given in a frequency table. But you could also be asked to just read the information directly off a histogram without a frequency table. So now we have no more frequency table. We have to go and read things directly off the graph. So reading the histogram. So what are the kinds of questions you could be asked? You could be asked, how many students were surveyed? So if this is the case, you have to read each bar in your graph to see how high it is, what was the frequency, and then add them all together. So 1 in the first bar, you have 14 in the second, 3 in the third, 5, 6, 2, and 1. So you add this all together and you have 32 students. Another question you could be asked. Greatest amount of time spent. Okay, so this is purely being able to read what is on the graph. You have 360 and then it goes on from 360. So the greatest amount that could be answered is over 360 minutes. 360 plus minutes. How about most popular amount of time? So in looking for this, I'm looking for the one that is the highest. My highest is here. And so I have to recognize how to read this. It starts at 60. It ends at 120, but it actually, in terms of the bar, it ends at 120, but actually it goes from 60 minutes to 119 minutes because this is the end before it starts the next one, because this would be 0 to 60. This is from 60 to 119, 59 minutes in each class. How about the amount of students for the most popular? In this case, it's not asking me which column it's in, it's asking me how much this represents. So it was here, and that would be 14 students. So basically, like, you can be asked about things on the x-axis, you can be asked on the y, you could be asked on the population, and then you can be asked specific groupings. So let's take a look at the next one. The number of students that work between 120 and 299 minutes. So 120 starts here, and I'm going all the way to 299. So basically, I'm incorporating this amount. So I have 3 students from 120 to 180. I have 5 students from 180 to 240, and I have 6 students from 240 to 299, and that will give me 14 students. How about the difference in students between the least and most times spent on homework? Okay, so in this situation, the least, I have 2 options. I could say that that is from 0 to 59, because that's 1 student. Or I could say it's 360 plus, also 1 student. But the point is that it's 1 student. The most is from 60 to 120 minutes, and that is 14. So I have 14 minus 1 equals 13 students. One last thing, a normal distribution, and you talk about this a lot in statistics, tends to have a symmetric distribution around a mean, and a mean is just another word for average. So basically it looks like this. Here's what the most people have, and it slopes equally on both sides. Last question, does this histogram look like a normal distribution? So is the big bump in the middle and the 2 sides the same? Whoop, whoop. So the answer is no, because it would have to look something more like this, so more like this, and it does not.